I am Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about network programming and management subject, in which the topic is SNMP management information. SNMP means simple network message protocol management information. Here, with help of this the protocol, now we can manage the information, whatever the information we are communicating between the two devices, that information can be managed. Here, this is the meaning of the SNMP management information. SNMP, which is stands for the Simple Network Management Protocol. So mainly it is the application layer protocol. So this application layer protocol now, which is include the internet, the protocol should. Here, the set of most commonly used communication protocols should be used online. Mainly, these simple network management protocols now we can use at the application layer. So, if you take the OSI reference model, now in a OSI reference model, the number of layers are 7 layers. Number of layers now, layer, physical layer, data link layer, data link, data link layer, and network layer, network layer, transport layer, transport layer, session layer, session layer. Sixth layer is a presentation layer, presentation layer. Seventh layer is a application layer, application layer. By supporting of these layers, generally we can establish the communication between the two other devices. Here is these SNMP protocol, that is simple network management protocol. It can be used at application levels, any application levels. Generally, the clients are which are running the many number of application. So in this the application now we can utilize the simple network management the protocol. By utilizing this simple network management protocol, now we can establish the effective communication between the two other devices. Here, which include these are the protocol for establishing the communication between two other devices. Now, it will including the internet protocol shoot. With help of this internet the protocol shoot through the online, effective communication can be established between the two devices. Here, generally these are the protocols now we can use, we can utilize in a online other communication. Here generally these are the protocol, SNMP protocol at application level, it is used in a network management. Here is, it is now we are using in a network management. So these are the network, it may be the private network, it may be the private network, or it may be it is a public network, private or public network. Now by using this SNMP the protocol, now we can manage, and these are the network, private networks and public network. Now we are monitoring the information the transmission, how the information is the transferring from one the private network to the public network. So that can be managed. Here is, now if you take the management console, so in this the management and the console, in this the system, if you are implementing the application layer level, here the number of the applications will be running on a on this, in this the console, in this the host here. So One of these application, if you take the one of these application, that applications which is utilizing the SNMP protocol. So this SNMP protocol now, what it is doing, so which is the monitoring, which is monitoring the server, how the how the server is the working while while communicating the devices, two devices. Now how it is the server is the working, and how the switches are the working, how the printer is the working. So for and routers, how the routers are working, so which will be the diagnose the problems, diagnose the problems and identify the other problems now, which is monitor. Everything is other monitoring. So while other communicating to other devices, to other computer devices, in between these now, while you are going to other communicating between these two other computer devices, so it will be the carefully monitor and establish the effective other communication. Here is this management information can be done with help of this other protocol, SNMP other protocols. Mainly these management information, it is nothing but it is a collection of information which is organized hierarchically. That means hierarchically means here the data, particular organization data can be stored in a MIB database. Can store in a MIB database. Whatever the data we have stored in a MIB MIB database, that the data can be arranged, organized in a hierarchically. Hierarchically means in a tree structure form that can be organized. So here, so this whatever the data we have organized in a hierarchical, so that can be accessed by using the protocol, SNMP protocol. Here with help of this SNMP the protocol now, we can access the information, the hierarchical information based on the levels, level 1, level 2, level 3, the number of n number of the levels now we can arrange in the data in a database. Generally, each entry in MIB database, it is identified by an object identifier. With the help of this, the object the identifier that can be identified. Object identifier. Here is what is the job of the object identifier means, now which is identifying the objects. What are the objects now we are utilizing between the source and destination. Here in this the source and destination, how many the objects now we are the utilizing. So it will be the identified. That means a globally uniquely identified by using the, so identifying the managed objects between the source and the destination. So it is a hierarchy. In this the hierarchy now we can arrange. So these OIDs can be arranged in a tree structured form. Just commonly here, commonly now we can use the object identifier in a network management. The identifiers are now generally we are identifying the SNMP object identifier, and what are the applications? What are the applications now we are running at the source side or at a destination other side? So what are the objects are utilizing for running the applications, so that the applications can be identified. And routing means here now what it is doing, the routing which establish the best and effective routing from source to destination. Whatever the information, whatever the data we are transferring, so it will be delivered in a number of ways or number of routes. But among the number of ways and number of routes now, what we are doing, the best path now we are going to finding the best other path. Here is now we are finding the best other path for reaching the destination. So this is a routing object identifier, system identifier. From which system now we are the system identifier, from which system to which system we are establishing the other communication, we are transferring the other data. So it will be the identified. And interfaces. What are the interfaces you are using? What are the other routers you are using? How many other switches you are using between the two other devices? Though that other interfaces can be identified. That is a interface object identifier. Here is message information MIB as a structure now. If you see, this is the MIB as a structure. So in the tree form now, we can represent. For example, the organizations now, if we take the organizations, the root of the MIB has a main branch, that is ISO. ISO is the first, the ISO, it is a main branch now. So it will remaining .org. .org means here this is the organization, related organization in MIB architecture. This is a MIB architecture. So that is a message information base, message information database architecture. Here in this message information database, so we can store the data. .org means whatever the .org organization data can be stored, and .dod .internet, the internet the data can be .in. So that can be stored here. So the storing data in a database, that can be represented in the form of the hierarchical form. Hierarchical representation is the most the important in a SNMP management information. Here is, these are the structure, these hierarchical structure, these are the tree are the structure in MIB. So with individual objects at the leaves, each object is identified by using the unique object IDs. That is, you are using the unique object IDs. By using the unique object IDs, so that can be identified. Here is ISO 1. The unique object identifier is a 1. By using this unique object identifier, it can be identified. And if we see remaining objects, ORG 6. ORG 6 now. 6 is a unique identifier. And here is the next Internet of 3. Internet of 3, INT3. INT3, it is a unique identifier. With help of this the unique identifier now, we can identify the objects and so the sequence numbers which are separated by the dots in unique identifier now, while giving the sequencing number. So here if you see, so number of the sequence 1 1 3 6 1 4 1, these are all the sequencing numbers now, so which is separated by the dot. So these all are the unique identifiers. One unique identifier, 6 and 3, so which identifying the organizations, which organization the data we are storing. With help of these the unique the identifiers now, we can identify the data, whatever the data we have stored in a hierarchical structure other form. Here is the hierarchical structure now, which is starting from the root and branches out to including the various standards and private entities. Here here now we can see key subtrees now, which is going under this structure is first the subkey is a ISO 1 unique identifier 1 and .org 3 and .dod 6, internet 1, directory 1, MGMT 2, experimental 3, private 4, security 5, SNMPV 2 6. Here with help of these all unique identifiers now, we can store, we can identify the objects, whatever the objects now we have stored in a SNMPV2. Here that objects can be identified. By identifying these the objects now, here the effectively we can transfer the information from one device to another other device. Here for transmitting the other devices, it is a one device, so it is a another device 1 and device 2. For transmitting the information from device 1 to other device 2, So number of the interfaces and that can be identified, and monitoring the interfaces. If it is working well, now we are transmitting the information between two systems or two other devices. Here is now the branches and their the significances in a management information generally .org, .iso, .dod, .internet. Here is unique identifier. Each unique .oso unique identifier is one, and .org unique identifier is a three, and internet dot dod unique identifier is a 3, and dot internet unique identifier is 1. So this is the main branch of internet related objects. Here also the directory. Now if we see the directory, now we can specify the sequencing number as 1.3.6.1.1, which contain the entries, the sequence number which is contain the entries. That means the data can be stored based on these entries. So 1, that means here it is a dot ISO data that can be stored in a directory, and a 3 dot org related information can be stored in a other directory. Here the dot the 6 any DOD related the information can be stored in a directory. So in these are the sequence. Now, if you want to store here these are the sequence, by following these are the sequence, now we can store the data in a directory mgmt. mgmt, so 1.3.6.1.2, so which contain a standard management information. So it is a standard management information, that is MIB2. MIB2, it is nothing but the enhancement management information. MGMT is management information. For example, MGMT example is MIB2. It is an enhancement for MIB. Next, the experimental, private, and so these are all which is containing one sequence for storing the data in a hierarchical form. Security, if you take the security and SNMP V2, all are the containing the objects which is related to the security, and SNMP V2 version 2 which is containing the objects which is related to the SNMP protocol, simple network management as a protocol. So that related information that can be stored in a hierarchical way. That means in a tree or the structure form, we can store the information. So these are the subtrees generally which is used by the different other companies. That means the companies or the domain is now we can differentiate with .org, .in, gov.in, government. Gov.in means here all government related organizations. That is enterprises, any enterprises which is defined their own management information basis database. Management information database. Here each company, whatever the companies we are taking, each company is assigned a unique enterprise number, that is 1.1.3.6.1.4. So these unique sequencing number can be utilized for effective communication and secure communication between the two devices. Here is some of the examples for the information management. MIB2, that is a request for comment 1213. So MIB2 is it is nothing but it is a extension or enhancement for the original original MIB database, message information database. See here is one of the most commonly used MIB database now, which includes the objects for managing the TCP/IP based internets. Now, system dot system. Now, if we take the system, the sequencing number for this data management is 1.3.0. 6.1.2.1.1. That means general information. Here, generally, we can store the information in this sequence only. First one object identifier. Next, third object identifiers, sixth object identifiers, identifier 1, identifier 2, identifier 1, 1. Here, like this, in this the sequence only, we can store the data, we can store the objects into the database. That is a MIB at the database and the interfaces. See here same interfaces also. So the information about the network, the interfaces. It may be the network interfaces. We generally we may use from private to public or public to private networks. Now we can utilize the interface. IP information about the IP layer and ICMP. ICMP means here, which is the information about the ICMP protocol. TCP means here information about the TCP protocol. So UDP protocol, SNMP protocol. Here, all these the protocol the operations can be performed. So that means here objects for the that can be managed. Whatever the objects now we are related to these other protocols, so that can be effectively managed and effectively maintained. Here is object identifier. Generally, it is a globally unique identifier. It is used to reference a specific managed objects. So specific managed the objects within the message information database. So the identifiers, object identifiers, so it is a series of the integers. Series of integers, that means series of integers means here the objects now we are storing in a series. So suppose for example NP. So it is a SN M SNMP. For example now if we take SNMP SNMP. Here is the object. Now we are identifying the objects, a series of integers. That means here in SMA 1.3.6.2.1.1. Here, like the series of integers. The series of integers now we can identifying the objects. Each and every the object it is identified as a number which is separated by the dot now by separating this the dot we can identify each and every the object. Here each and every object can be separated by the dot that the travels the MIB trees, hierarchical trees from the root object to the specific object. Whatever the object now we have to identify from home system to we want to transfer the information that system objects from root to system to the specific system objects now we can transfer the data. That is a object identifier. So examples of an object identifier. Here is now consider the OID. Consider the OID for the system the descriptions in MIB2, that is the enhancement. The sequence number is 1.3.1.2.1.1.1. Here is dot 1 is a ISO International Standard Organization domains related the domains. Dot 3 is a ORG domains. That means related ORG domain information that can be stored. And dot DO related dot DO information can be stored. For that, the identification number is a 6. Dot .org identification number is a 3. Dot ISO identification number is 1. All all ISO, ORG, DOD information can be stored. And internet. So internet means here all the internet related information that can be stored in a internet. And MGA management, information management related information or MIB2, and systems information that is a dot 1, and system, DESC, CR. These are the information. So these are all the object identifiers. So in a information monitoring or in information management system. Here is understanding the structure. So in understanding the structure now, first to manage the devices effectively, to manage the devices, two devices effectively. Between these other two devices, whatever the interfaces you are using, whatever the devices you are using, you have to monitor that other devices for effective communication. By monitoring only, we can successfully, effectively sending the data to the particular our the expected the destination. Here is SNMP manager what it is doing, which is using the MIB structure architecture. So MIB, the architecture structure, with help of this, the architecture, with help of this, the structure now, we can maintain the data in a hierarchical way and transmitting the data effectively by identify and access the required management information. Whatever the whatever the information, whatever the information you want to manage, that the required the information can be managed. Here is the hierarchical structure now, which is ensures a very clear and organized way to addressing each managed objects. This is about the understanding the structures. And common MIB or MIB2, that is RFC 1213. RFC 1213 now, which is extends the original MIB and including the objects for various protocols. That means here this RFC 1213 request for comment generally in a MIB2 in a enhancement, which is includes the TCP, UDP, IP, like this. No number of other protocols can be utilized. So that's why, so various the protocols that can be utilized and storing the data in a hierarchical other form, and with help of that hierarchical form data effectively transmitting and sending the data to expected other destination. Host to resources, that is MIB, request for other comment 2790. So which is provide the information about the host, hardware and operating system. Here is if MIB request for comment, that is 2863, which is managing the network interfaces. And SNMP3 generally now we are perform the operations are get request and get next request, get set request, get bulk requests and trap, inform the request. Generally, these operations can be utilized while using the SNMP protocol at application layer level. Here, at application layer level in OSI reference model, while using at application level, these are the protocol which perform the different operations to communicating between the two devices. The device is a manager and agent devices. One device is a manager device. Here is one device is a manager device. So another device is a agent device. So it is a agent device. So this one is a manager device. Manager device. From manager to the agent, the effective the communication. Generally, we are using all these the operations with help of the SNMP protocol. Here is get request now. What it is doing here? Now requesting the value of a specific variable. Whatever the variables now we are transferring, so that the variable specific value can be requested. That means the sequencing number already we have discussed. That is a 1.1.3.6.4. Here the value of a specific variable, that is the variables are A, B, C. So A the specific the value is 1, B specific value is 3, and C specific value is 6. Here the specific values that can be requested. That means which sequence of data need to store in a MIB. This value here, the requesting value, which indicates what data we have to store. And get next request. Get next request means here requesting the value of the next variable in a MIB, hierarchically or in a tree structure form. Set request. Set request means here sets the value of a specific variables. Specific variables. Whatever the specific variables now we are using, now we are setting the values. Get bulk request. Bulk request means now which is requesting the bulk amount of data, bulk amount of the packets from one device to the another computing other device. So this get bulk request now what it is doing, now optimizing the request. That means optimizing the request means number of requests the times will be reduced. Here to retrieving the large bulk of the data, so that can be requesting time by reducing the requesting time now bulk amount of data can be accessed. And asynchronous notifications from an agent to a manager about the significant event. Inform request. Inform request means here acknowledged notifications from an agent manager. That means here generally SNMP two versions and later generally. So these should be utilized in a inform request operations. So versions. If you take the simple network management as a protocol here, so we are utilizing the different types of the versions. The versions are generally we are utilizing the original SNMP V1, SNMP V2, SNMP V3. In SNMP V3 version, there is a first version of the SNMP. Here, this is a original version which is defined in a RFC request for comment 1157 porting number, which uses the community strings for authentication. Here, SNMP V2. In SNMP V2 now, which is introducing the improvements, which is including more efficient bulk retrievals. More efficient bulk retrievals can be included, and more the detailed error reportings can be considered. Here is defined in a RFC 1441 to 1452. Next the version is a SNMP V3. In SNMP V3, what we are doing? So we are providing the high security. So whatever the data you are transferring from device, from in between this the device, between the device, whatever the data we are transferring here between the devices here, we are providing the high security. And also remote the configuration. Remote the configurations also we can provide, which is the defined in a request for comment 3410 to 3418, which is providing the very high authentication and authorization, and also provide by providing of this high security now, which is encrypting and decrypting the features. By encrypting and decrypting the mechanism, SNMP V36, which is provide the high security comparing than the other versions, that is SNMP V1 and SNMP V2. And management tasks are monitoring the network performance, detecting, diagnosing network problems, and configuration managements, network as a security. So these are all the key aspects. Here, these are the tasks which is the network administrator can effectively use the SNMP to manage and monitoring the network related other devices. Here, monitoring the network, we are improving the performance. Like here, now by monitoring the routers in between the source and the destination. Now source and destination, we are arranging the routers, switches. We are arranging the switches or hubs or printer. So printer, number of other devices. Now we are managing the number of other devices. So between the source and the destination, between the source and destination here, number of devices can be managed. And here, so by managing this number of other devices now, effectively we can monitor and detecting and diagnosing the network other problems, identifying the issues while transmitting the data. If it is a delayed here, which is identify the issues where the issues are arise, whether in a router or whether in a switches or whether in a hub or whether in a printer, isn't it? Here it can be identified. All these the problems can be identified by providing the encryption, decryption also, which provide the high security for over the network. Whatever the data you are transferring over the network, so will provide the high security for the data. And outcome of the SNMP management information in a network, which includes the enhanced network of the performance monitoring and improving the fault detections and the troubleshooting, so efficient the configuration management, and also robust network health the assessment. SNMP also which aids the scalability and the automations, which ensuring the streamlined management of the large networks. Here is for SNMP management information, the textbooks are Unix network programming and network management principles and practices. The reference books are Networking with the TCP/IP, SNMP, V2, V3. So these are all the references, and web references. These are all the web references. 1, 2, 3, 4. These all now you can refer the web references. So this is about the SNMP protocol. Thanking you.
Like, share and subscribe. Hit the bell icon for more updates.